Folks, we got one last thing to do for the year, new stuff, and rather than take time to do it in class, we're going to get right to Regents Review. So I'm going to give you this to watch as a video. It's all on the reference table. It's going to be Table R, and it's basically going to be stuff that we add on, this extra stuff on our organic hydrocarbons that we've seen the last couple of days. So as you've seen the last day or so, as we start the organic chapter, hydrocarbons are just exactly what the name sounds like. It is molecules made up entirely of a carbon chain with hydrogen sticking off. And remember, every carbon can take 4 bonds. We saw that months ago in the bonding chapter. Each H only gets 1 bond. So they're basically just these side pieces that stick off the main chain of carbons. We have either alkanes, alkenes, or alkynes. Those are the molecules that either have single bonds if it's an alkane, a double bond somewhere in the structure if it's an alkene, or a triple bond somewhere in the structure if it's an alkyne. That's all on the other organic chart we saw. Substituted hydrocarbons are now going to be things where you kind of swap out some piece. So instead of having just a chain of carbons with some H's around it, you can actually, not that we would physically do this, but the structure will have an H missing and something else substitute on in its place. So we're going to use this thing over here on the right side, table R. It's in your reference table, and it just lists 9 different ways that something can be substituted on. So just like you maybe would say, onion rings for fries instead of, some kind of substitution at a restaurant, you can substitute out one of the H's for something else. So there's little groupings here. It has this little picture, this column right here where it says functional groups. This shows you what it actually looks like. These are the 9 things you might have. So maybe it's something from group 17 on the reference on the periodic table. Maybe it's an OH. Maybe it's a double bonded oxygen. All these different things. They have names in the first column. What it looks like is in the second column, and then the fourth column over here actually gives you examples of how to name it. So you don't even really need to remember how to do it. But I'm going to go through each one, try to get through really quickly, and show you how we can change these things and update the structure, where it's not just carbons with hydrogens, it's also this extra piece kind of added on. So this is what we're going to start with. Every example I show you, we're going to start with this as our kind of base chain, our main piece we're going to build off. So we've got 5 carbons in a row, all single bonded hydrogens around it. So this is going to be an alkane with all single bonds. Because it is 5 carbons, our name is going to start with pent as the prefix. And again, all single bonds is going to be alkane, so it's going to be called pentane. This is pentane right here, and then we're going to substitute some stuff. So maybe we'll knock off an H and attach an OH. Maybe we knock off an H over here and attach a chlorine or bromine. We're going to see everything based off of this molecule right here. It's going to be on every slide we do going forward. I'm going to give you 9 examples of how we can change this thing, update the name, update the structure, and see what these functional groups, these separate side chains are. They give these molecules different names, different properties, and different structures. So again, on table R, just notice the first column shows the class, the type of functional group, what we call the thing that's being added on. The second column shows what it actually looks like. So you can see F and Cl and Br and I and OH. The third column just gives you, a general idea of what it's going to look like in the picture form. And then the example naming and structure and thing is in the fourth column where it actually reminds you what you can name this thing. Once again, we're going to use this molecule up here, which is pentane. It's just 5 carbons in a row, all single bonded hydrogens. So everybody's saturated, everybody's attached somewhere, and we're going to see how we can change this thing. So let me draw a line right down the middle of the screen to kind of divide this up. I'm going to start with what's called a halide. Halide, notice the name sounds like halogen. Those are the group 17 elements, and those are exactly what you're looking at here. Look at all these elements that are in group 17. So our buddy fluorine, chlorine, bromine, iodine. If we take our 5 carbon chain, so I'm just going to draw my 5 carbons here, and we substitute one of these elements, FCl, Br, or I, in for one of those hydrogens, that would count as a halide. So like if I now just, let's say, instead of having H's all around, I put a, let's say, don't go with fluorine, just that's different looking. I put a fluorine on the second carbon there. I'm just drawing these lines to save time, but all these little lines should have H's on the other end of them. So imagine there's H's everywhere, but on the second carbon from the left, I have substituted a fluorine on. So looking at a picture like this, fluorine is going to stand out as the thing that doesn't belong. It's not just C's with a bunch of H's attached. It's now this 5 carbon chain with a fluorine in that spot. This is the different thing. That's what I want to do for every picture like this. Say what's different here. What's not just a chain of carbons surrounded by H's. Fluorine is the thing that's different. So what we're going to do here, we would give it the normal name. I would call this pentane. It's still 5 carbons with a bunch of H's around it. And then I will just update my name to show the prefix for this element. So because I chose fluorine, the prefix is fluoro. So I'm just going to call this fluoropentane. So you're just updating the name to show that it's that extra thing attached. If there was a chlorine attached to it, you would call it chloropentane. Bromine would be bromopentane as it shows up here. And iodine would be iodopentane. So that's all you do. If you see the extra thing is something on a group 17 element, you just update the beginning of the name. So it's fluoro, chloro, bromo, iodo. and then the name of the main chain of carbons and hydrogens. Next side, we have now our alcohols. So what an alcohol is this as the extra piece. It's an OH. So if I have my 5-carbon chain, instead of just H's around, maybe now on a carbon, let's do it over here. I'll add an OH here. Alcohols have this OH as the special group, the extra thing. So the rest of these guys will all get just H's all around. Every carbon gets 4 bonds total, but now on that second to last carbon on the right, and now instead of just a regular H, I've substituted in an OH instead of just one H. So this would now count as an alcohol. And it shows us as the example right here, OL at the end. That's how you're going to change the name. So you say what carbon it's on, and you just say, okay, OL, much like the word alcohol ends in OL, the name of this thing is going to end in OL also. So instead of saying pentane, I would start to write that, and I'm going to instead write pentanol with an OL. So you just change the ending of the name to OL, much like the word alcohol has. So this would be pentanol, showing it has alcohol attached to a pentane molecule. That's the setup for this one. These next two are very, very similar to each other. So I'm going to do them side by side. And let me just start by drawing my 5 carbons first to get that out of the way. And I'll show you how they're different from each other. So a little space there. Now, if we look at what the functional group looks like, it shows a double bonded oxygen with a carbon, and there's an H hanging off, and it looks like that's the end of the chain. Remember, H is kind of where it stops. You can't go past an H because that's only one bond. And then the second one has a double bonded oxygen attached to a carbon, but it's got those bonds, those lines on either side, so you can have something on the left and on the right. So the first one's called an aldehyde. Aldehydes have a picture that looks kind of like this. It's a carbon with a double bonded oxygen, but it's going to be on the last carbon on a chain. So either all the way on the left or all the way on the right. Usually we see it all the way on the right, so I'm just going to draw that over here. So I'm just going to go all the way to the end of my chain, and I'll draw a double bonded oxygen coming off that thing. Now, this carbon all the way on the right has the single bond to its left, that right there, and now it's got these 2 bonds from the oxygen, so it only gets 1 more bond additionally. So I'm just going to do another bond somewhere. I'll do it on the bottom just because it's a little bit easier to draw it down there. So this would have an H down there. You could also do it to the right, whichever. And then again, all the other carbons just get enough bonds to have 4, and they're just going to have H's around them everywhere. Again, all those lines I'm drawing should have H's on the other side. They should all look kind of like this, just as an example, but just to save time and energy and space, I'm not going to draw H's everywhere. So that's what an aldehyde would look like. Aldehydes have a double bonded oxygen on the very last carbon, either all the way on the left or all the way on the right side of a chain. The name, as you can see again up here in the example, much like the name starts with aldehyde, has AL at the beginning, you do that, you end with now AL. So this would not be pentane. You'd write pentanal, AL. For the alcohol, it was OL, because that's what alcohol ends in, OL. So it became pentanol. This is pentanal with an A. Slight difference, but something to look for. Ketones are our next type of molecule, and this looks almost identical. It's just that the double bonded oxygen is attached to one of the carbons that's not on the end. So if it was the carbon all the way on the left or the carbon all the way on the right, it would count as an aldehyde. If it's literally any of these other carbons that are not on the end, so like for example, this one right here, that would now make it a ketone. So a double bonded oxygen anywhere that's not the last on the left or the last on the right, that counts as an aldehyde. Any of the carbons somewhere in the middle of the chain with a double bonded oxygen, that now counts as what we call a ketone. And again, the name kind of shows you how it's going to look. So much like the word ketone has that "one" at the end, that's what you do to the name of this guy. So instead of pentane, kind of starts the same, but then it becomes pentanone. You just take that E off the end and make it own, like ketone. So pentane becomes pentanal if you've got the double bonded oxygen on the very end, and pentane becomes pentanone if it's the double bonded oxygen is somewhere on the interior, somewhere in the middle. As long as it's not on an end, either all the way on the left or all the way on the right, it counts as the middle. So that's pentanone now. Next one is organic acid. For this one, it's going to have the last carbon on the chain, again, either all the way on the left or all the way on the right. Typically, you'll probably see it on the right. And it's not just going to have that double bonded oxygen like we saw for the aldehydes. It's going to have a double bonded oxygen, but then also an OH. So if I draw my 5 carbons here, The last carbon will have that double bonded oxygen, like we saw with the aldehydes, but it also has an OH. So it looks kind of like an aldehyde if it also had sort of what looks like an alcohol on the side of it. Just look, this is the extra thing. This is the thing that's not just an H sticking off the molecule. You got that functional group of the double bonded oxygen and also the OH group. So it looks, again, like an aldehyde and alcohol kind of combination, but that's organic acid. So for this, we changed the name ending to be oic acid, as it shows in the example up here. So instead of pentane, I'm going to, again, start to kind of write that, and I'm going to leave the E off. So pentane, I'm going to just get rid of that E at the end and make it pentanoic acid. Once again, it gives the example in this last column where it says propanoic acid. That's if it had 3 carbons instead of 5. Be propanoic acid. So just find your carbon chain, however many carbons is, that's your prefix, and then change the ending of it to oic acid. The next one is esters, and that's kind of weird. This is actually sort of like 2 carbon chains joined. So instead of these 5 carbons, maybe I have like 3 carbons in a row, and then you'll have this double bonded oxygen that goes up, and on the other side, another oxygen and another carbon chain. So the rule for this is name whatever's over here. This is kind of the weird one. Name however many carbons are in this direction. So this is 2 carbons. So I would just say ethyl. It's not actually ethane because it's not a separate molecule, but it's still the same prefix. So ethyl. And then name this number of carbons, which is 3 on the left side. And that's going to be prop. And then you do this weird O8 ending. So it's prop, not propane, but propanoate. This is a weird one. Just the thing to know about this is if you see a weird name like this with 2 words and that O8 ending, just come check table R. It's going to be an ester. That's all you got to know. You're not going to have to draw this thing. Just know that's going to be an ester. It's got the double bonded oxygen with the extra O, the weird O8 ending, ester. All you got to know about that. These are the 2 groups that have nitrogen as part of them. Their names are going to be amines and amides. Very similar. In this one, it's going to be nitrogen with some number of carbons around it, carbon chains on either side. And this one's going to be a carbon with a double bonded oxygen and then a nitrogen. So again, just if you see nitrogen, there's only 2 spots on this table where it has nitrogens. One of them is going to be just nitrogen in the middle, and the other one's going to be carbon double bonded oxygen with nitrogen in the middle. So just if you see anything like this, nitrogen with some number of carbons on one side, some number of carbons on the whatever it is, let's just make it one carbon. Actually, let me erase that. Let's say I have my regular 5 carbons here. There we go. My 5 carbons in a row, so it looks kind of like propane, or pentane rather. And instead now I've got a nitrogen attached to this thing. I'll just add it over on the left side here because that's where it kind of fits. So you got a nitrogen with then 5 carbons in a row instead of pentane. Once again, we're just going to update it, and you can see by this ending over here on the end of the thing, it's just you add this word amine to the end. So instead of pentane, I just get rid of the E and make it pentanamine. Instead of pentane, it becomes pentanamine. You literally just add that word right there, amine, to the ending. Pentanamine. That's it. The other one's pretty much the same thing. It just, instead of 5 carbons here, calling it pentane. Now this has that double bonded oxygen on the end, plus some nitrogen with some H's attached to it, and that's the Q that it's what we call an amide. So much like the last one, instead of pentane now, you again just get rid of that E, and now you add amide instead of amine, so it becomes pentanamide. Weird names, similar names, but it's just again the difference. It's either N by itself or the double bonded oxygen with the N, and then you just change it either to amine at the end to add it onto the name, or amide added onto the end of the name. But again, all on table R. Don't try to memorize. Just go and check what it says. I say this for last because it's my favorite one to name because it's the fun one to name. These are called ethers, and they look like little belt buckles, I think. It's actually going to be 2 carbon chains attached by this oxygen. So it's oxygen like a little belt buckle, I always think of it. So instead of our 5 carbons, we could say add like 2 carbons on this side as a chain, and then I'll have this kind of oxygen belt buckle in the middle, and then let's put 3 carbons on the other side. And what you're going to do to name this thing is, again, it's called ether, so the name is always going to end in the word ether. That's always going to be the last thing. And you just kind of name how many carbons are on either side. So like over here on the left, I see two carbons. Now they're not a separate molecule of two carbons where you call them ethane. They're like a little mini version of that. So instead of ethane, we call it ethyl. It's kind of like ethane. It's ethyl. And then on this side, we see three carbons. If it was a three carbon chain by itself as in one entire molecule, you call it propane. In this case, we're just going to call it propyl. It's sort of like propane, but it's like a little mini version. And then again, you just end with the word ether. So it's ethyl, propyl, ether. You can see on this molecule, this example up here, there's a one carbon group, and then the O, and then a two carbon group. So that would be like this, one carbon, an oxygen, and then two carbons in a row. So because one carbon's over here, you'd say methyl. Because two carbons on the right, you'd say ethyl, and then again ether. Methyl ethyl ether. It's just fun. If you had two carbon groups, it'd be diethyl ether. But methyl ethyl ether, you could have methyl methyl ether, propylpentyl ether, whatever. I think it's fun. I don't know. Maybe you disagree, but it's fun to say. That's it. We're officially done. Go to Schoology. You got 13.2 works. Your last thing on there. I know tear running down your cheek right now, but go do this. Don't get freaked out by these things. It's all in the reference table. Just go to table R, find your carbon chain, know what your prefix is from the one chart. It's all single bonds and double bonds. Make it ane or ene or ine. It should be anes. And then just see what is the separate piece. What is the different thing that's not just H's hanging off carbons? See what that looks like on table R and adjust your name as needed. You're going to have like maybe one question like this in the Regents. Don't get freaked out. Just look for it on the table and it'll all work out fine. So go work on 13.2 and we are officially done with all this stuff.